Okay, good morning. This is Dr. Baker. I'm just signing in and creating a short little video to talk about where you should be in the class and what should be going on this week and where you should be to be staying on track. So if we look at the course homepage, you can see that, sorry about that, I can't for whatever reason, I'm having trouble turning off alerts. So if you see Facebook alerts and texts pop up, I apologize. Couldn't get that setting to work this morning. Okay, so here is your course page. And if you look, here is Module 1. Module 1 goes through, has 15 lectures, and it goes through, I believe, sections of chapters 1, 2, 3, and 5. At this point, you should be primarily finished with the homework problems in chapters 1 and 2, which would be first and second order differential equations. So let me pull up a section from your textbook. This is from chapter 2, section 5, looking at Euler equations, because this is relevant to a couple of the homework problems. So if we look at the Euler equation, it's a ordinary differential equation of a specific form shown in this top equation, equation 1, where there is a second derivative in y, and then that's multiplied by x squared. The coefficients to the first term has been divided out so that the second term will have a coefficient of a, and the third term will have a coefficient of b. And then basically the assumption is that y is some x to the m, and then basically you get y prime and y double prime. You substitute that back into the equation, and what happens is you get an auxiliary equation that looks like this, that can then be rewritten here. And so what I want you to note is that the middle term in this auxiliary equation has a coefficient of a minus 1. So in one of your homework problems, you're actually given m1 and m2, and they happen to be the same, so it's a double root. When you come into your auxiliary equation and substitute in for m, um, you actually don't get, if you substitute into this equation, you actually don't get the correct equation. What you have to do is you have to come back to equation 1. And so what you're substituting for is the constant b, which is the same constant as what you have in the auxiliary equation. If we look here, sorry, went to the wrong thing, equation 2. It's the same as the constant in the auxiliary equation. But the middle term, the term that multiplies xy prime, actually has the coefficient of a. And if you come down to the auxiliary equation, what the auxiliary equation yields is a minus 1. So you have to basically take whatever that coefficient a minus 1 was and get it in terms of a. So that's how if you're given a solution, you work backwards and find the original ordinary differential equation. So here would be your two real roots. We have x to the m1 and x to the m2. Okay, so that addresses one of the homework problems that I received numerous questions on from chapter 2. I do want to address a couple of other things. One that went out in an email yesterday. And while I'm doing that, I'm gonna open up your textbook reading assignment. It went out in the email yesterday, basically on the homework problems when you're asked to give a solution and there's a constant, so it would be like a general solution. And I believe this is on one of the problems where you're determining exactness. So in one of the problems where you're determining exactness, you're asked to give the solution, and I know the homework problem is a little bit different for everyone, but if you just solve it directly, you get a constant times x to a power plus the same constant times y to a power. And I think that constant, it depends on what your problem is, but one of the things I looked at, it was like 1/4, and then that's equal to another constant. What Wiley Plus is looking for in their solution, and this is not what I want to do. What Wiley Plus is looking for in their solution is they're looking for the equation equal to a constant where if you have a common constant for every term, they want that included in the C. So in other words, to make that more clear, instead of saying like 1/3 x cubed plus 1/3 y cubed is equal to C, you would want to say x cubed plus y cubed is equal to c, and you'd want to incorporate that common coefficient into the constant in the solution. Otherwise, Wiley plus is going to count your answer wrong. Even though I can see what you're doing and I know that it's not wrong, what Wiley plus does is they will count it wrong. So let me go here and open your textbook, and we'll look just really briefly um, at some of the content in chapters 1 and 2, and I'll do this in the context of talking about the kinds of problems that you might find on exam 1. So just from chapters 1 and 2. So obviously the separable ordinary differential equations is a part of this. The concept of exactness, this is a concept that's fairly easy to test. There are some governing equations. And so this is an important concept that you get down, being able to check if an equation is exact. If it's not exact, to see if you can come up with an integrating factor. That's something that's important to study for the first exam. Also, separable equations. We will not talk a lot about modeling, but you did have a couple of homework problems where you had to show that equations were separable, and so something like this would be a good example. Any of these examples in the textbook, you can expect that questions, okay, so we will not actually cover modeling. So you can expect that questions on the exam will be more similar to what you see in the example problems worked out in the book than they would be to some of the homework problems, because some of the homework problems accomplish a different task. They basically are looking for, a little more lengthy work. We will not have anything covering reducing to separable form like example 8, nothing like that on the exam. So that would cover that section. Then if we go to exact differential equations, this test for exactness, that's important to know how to do that. Finding an implicit solution, solving an initial value problem, also important on the first exam. In the case of non-exactness, there is a discussion of finding an integrating factor. Now, I linked you to some notes that I think are slightly better than what's in your textbook, and so if you are, having issues with understanding what the textbook is doing on their discussion of finding an integrating factor, then I highly recommend you look at that little link that I put in the Blackboard site. So I'm not one who tests on theorems or asks for proofs. Any problem that you would be given would be very straightforward, similar to the the finding of an integrating factor in an equation like this. Also, if you look at those online notes that I linked to, they also have a couple of pretty good example problems for finding integrating factors. There was some discussion and coverage of linear differential equations and Bernoulli's equation. Bernoulli's equation is a very important equation in engineering, and so for that reason, being able to solve Bernoulli's equation is also important. This is just an example. Once again, if you look at example 1 here, this is pretty straightforward. We will not be looking at electric circuit examples or hormone levels or anything like that. It will just be a simple mathematics kind of problem. So here's a discussion of Bernoulli's equation. Here's the logistics equation. The logistic equation is also kind of an important equation. Um, if I want you to do something with one of these equations, you'll be given the equation form. So population dynamics, phase plots, none of that. So we're just looking at simple general solutions of initial value problems, whether they be Bernoulli's equation or just linear differential equations. Finally, the section on existence and uniqueness. Here is one area where I am looking, at do you get the basic concepts that you have a certain number of solutions and um, sort of the concept of uniqueness. Um, you can read the information there. This is the student solutions manual and study guide. You should be able to link to this easily. So anyway, that is the gist of the material. So once again, to summarize, most important material from chapter 1. Let's see if I can't get back there. Chapter 1. Well, for whatever reason, I can't seem to get back. Anyway, so just the very simple ordinary differential equations. Chapter 2. Okay, so certainly we covered homogeneous linear differential equations of second order. This will constitute a significant portion of the exam. So given a second order differential equation, as you know, if it is ordinary and linear, if it is constant coefficients, as you know, there's a limit to the number of solutions you can have, case 1, case 2, and case 3. I expect you to know these 3 cases. I expect you to be able to find them, and I expect you to be able to generate a solution. Do not be surprised if some of the exam questions in this section are multiple choice. So, I might present you with a differential equation and then give you some possible solutions according to these cases, and you would have to determine which solution is correct or what the general form of the solution would be. So anyway, I anticipate this exam will not be 100% you working out problems. Some of it will be questions where you're given either true, false, or multiple choice based on things like this. Differential operators, that I treat it as an optional chapter. Some people enjoy differential operators. To me, it is redundant of the Laplace method, so I don't really teach that as a method of solution because I think Laplace is a lot more powerful. So anyway, sections 1 and 2 constituting the bulk of the material from this chapter. Next, skipping up to the section on Euler equations. We already had a little bit of a discussion on that. Hopefully, here we go. So this is Euler-Cauchy equation, and we had a little bit of a discussion on that. What we discussed was real roots, but as you know, you can have a double root, and you can also have complex roots. And so important to know the general solution forms. How many of these equations I'm actually going to give you, I'm a little bit undecided because I haven't made out the exam yet, so I don't have specifics of what the questions are and what formulas I think you may or may not need. I do not expect you to memorize every formula in the book, but you will not be able to use a cheat sheet. I will provide one. So I'll make the decision of what formulas you need, and I'll provide that to you before exam time so that you can see what formulas I'm giving you. So for example, I could see maybe giving you this formula, but you would have to know what it was and when to use it. So hopefully that makes some sense. The Wronskian, yes, I expect you to know how to calculate the Wronskian. I expect you to understand a little bit about linear independence and general solutions as well as particular solutions. Now let's look at non-homogeneous differential equations. Same thing here. In this case, you're shown that you get general solution and particular solution, the general solution based on the homogeneous part of the differential equation, the particular solution based on the inhomogeneous part. And so I have been known, for example, in classes in the past to give a differential equation that was non-homogeneous, to give the correct general solution and ask people to find the particular solution. So that's just one example. We will focus, of course, on constant coefficients because that's much easier and more doable. The method of undetermined coefficients is probably one of the most powerful methods and fairly easy to apply. The modification rule happens when you have double roots. So double roots to the characteristic equation. And so in this case, this would be an example of an equation that yields double roots. And so you have a double root of 1.5. And so in that case, you have one constant, e to the minus 1.5x, and another constant times x, e to the minus 1.5x. And that rule is continues. So if you have a triple root, you would have a c3x squared, and so on. So I definitely expect you to have an understanding of how to do that. And then the sum rule, of course, is another, important concept. Sections 8, 9, and 10, we did not cover. We did not cover section 4. We did not cover section 3. So hopefully that reduces the amount of material that you have to work with, study, and look at. Once again, I would look closely at. You have a solutions manual and study guide. I would look closely at some of that stuff because we'll just walk through here. This is a nice summary, and then they have several worked out problems. And so if you need additional assistance on anything, here's for section 2 an example. Here's the differential equation, here's the characteristic equation, here they've solved it, and here you're given the solution. So that can maybe help you if you feel you need additional practice. Now, where should you be? At this point, if we go back to Blackboard, this homework assignment, I believe homework assignment 1 for module 1 is due a week from yesterday. So you should be more than 50% of the way done there. So if you're not more than 50% of the way done, you're behind, because I can tell you second half of the homework assignment, the problems are a lot longer and a lot more time consuming. How much will we cover on the exam from series solutions and some of the materials in that chapter? Not a huge amount. The questions will be more likely to be not a full worked out problem, but a part of a problem or a concept used to work a problem, or something along that line. So I can't expect you to find a full series solution in a 2-hour exam that's closed book. So unless it is a very, very simple problem, and I give you some formulas to help you do that. So that will not anything like that would not be a full-fledged problem without some kind of input from me to assist you. But you should know how to do it. So anyway, that is that's where we are there. The materials from Module 2 are primarily Laplace and Fourier analysis, and I will try next week to give you a little summary video and let you go over some of that next week on chapters 3 and 5, and then we will also look at kind of an introduction to Module 2. But you should be wrapping up Module 1 by the end of this weekend. If you have any questions, I did not receive any other questions on the homework. I was looking to kind of give people an opportunity to email me questions. I didn't get any additional emails, so I've covered I believe most of the questions I got on the homework in this short video. And if you have any additional questions, I'll try to make another video. I would ask if you do have questions on chapters 3 and 5, if you would please try to get those to me by Sunday evening, and then that allows me to release the video a little bit sooner before the homework due date. Um, and that will hopefully then be helpful. Oh, and there is one other thing. I've been unable to go into Wally Plus and get it to give you 100% for the third try on the questions. So that's probably something I'm going to have to either go in and adjust manually. I'll probably just go in at the end of the semester and see if it makes a difference in your grade to add that extra 0.05. It's giving you 0.95 if you get it right the third time. For whatever reason, the system just does not allow full credit after 2 attempts. And I have not found any way to change that option. So I just wanted to give you a heads up on that. I did say on the syllabus you would have 3 attempts. I certainly stand by that. You're just going to have to not stress when you see that it takes off 5%. All right. Also, please keep in mind that there are actually more homework problems than the 80 points in the class. So it's probably okay to miss a couple problems